Alright, welcome to 8.3b. 8.3a was all about the quadratic formula, and we kind of ended on the note that we had 4 different types of things happening. Okay, so this video is about the discriminant. We'll talk about what that means in a sec, but if you remember, we ended with the 4 different types of answers. We had real numbers, like 4 and 7, real rational numbers. We had rational numbers, but they were still real. There was 1 plus or minus root 3 over 2. Those are just irrational. They're still real. They're still positive and negative, but they are almost impossible to write as a single number, right? They have infinite decimals. There was one where we got one answer, and then there was one where we had I in there, or had a complex answer. So, how can we tell what's going to happen in the quadratic formula? We can tell that by something called the discriminant. This is a very special part of the quadratic formula, and it's not discriminate. We're not discriminating against anything. It's the discriminant. It's just describing. Okay, it's a describing term. This thing right here may look familiar. This is the formula for the discriminant. This is what's underneath the radical in the quadratic formula. So your discriminant is just that thing that's underneath the radical, the b squared minus 4ac. This is the factor that leads us to what type of answer we're going to get. We had one where we ended up getting square root of 0. That was the one that led us to only one answer. When we had perfect squares there, something like square root of 25, then we would get 5 as the answer, right? We would get a real number, a positive perfect square. If you had something that wasn't a real number, wasn't a perfect square, like 42, then you would get a positive but not a perfect square. You get the irrational answers, the plus or minus root 3 over 2. And then if you got something with like negative 12, you would get an I underneath. So, while I fully understand that you guys can plug into a formula, and I'm really excited about that, not really, I'm really not excited about that. Because many people can plug into a formula, and nobody's going to pay you to plug. A computer can plug into a formula really, really easily. It's just not something people pay for. So we need to have a thorough understanding of what's happening with that. See, that's the real job in the real world. You know which program to use because you know what it's going to do for you. Okay, so we're going to look at this more of a technical standpoint. Why does the quadratic equation give certain answers? That's what the discriminant does. So let's take a look at this little chart here, right? We kind of just talked about it. These are our 4 possible answers. This is what you would get. This is the discriminant, and this is the type of answer you'd get. So let's just look at this first one now. 6x squared minus x minus 15 equals 0. We could just jump to the answer, right? We could do the whole thing. But what if I didn't want to know that? What if I just wanted to know, does it factor? I don't want to say what does it factor to. I want to know, does it factor? Or am I only going to get one answer out of this? Or does this even exist? Is this x even real? Like, can I even solve this? What if I wanted to ask those questions instead of what was the answer? So really what I'm asking is, what type of solutions am I going to get here? The way to answer that is only to do part of the equation. Do half the work and see where it leads you. Okay, so let's do half the work. Let's just do the square root part. So just the square root part. All right, b squared minus 4ac. Let's just find the discriminant. Here in this case, a would be 6, b would be negative 1, and c would be negative 15. So let's go ahead and plug that in now. Negative 1 squared minus 4 times 6 times negative 15. We would get 1 minus negative 4 times 6 times 15, 360. So 361. Sorry, my pen freaked out. Okay, so 361 is what we're getting under the radical. Now, what does that mean? What is this number? Let's see, 361. This is kind of, we have other stuff over here, we have a plus or minus, we have other stuff over there. This is what we're seeing in the problem, right? So what does this mean? Well, what is 361? Does 361 square root? It actually does. It is actually a perfect square of 19. And so from here, I'm going to be able to actually add it and subtract it to whatever's the first term, and then divide it. I'm going to get some real numbers out of this. So this is telling me real rational solutions. And that is what I want to know. I don't want to waste my time. I don't want to waste my time doing this whole problem if it's not going to lead me to the things I want. So because 361, not 19, sorry. Because 361 is a perfect square, then I can actually finish the math and I can actually get some real answers. Okay, and that arguably is more important than just actually doing the problem. Okay, so that's the first one. Let's try another one. This one, not set up in the standard form, so good opportunity to redo that, right? So we can move it over. Now I'm just going to do the discriminant. What is the discriminant here? That would be b squared minus 4a and c. All right, here I get 16 minus negative 60, which would be 76. Okay, so once again, this is what, if we're doing the whole problem, this is what would be under the radical. And what does this tell me? This tells me that's not a square, that's not a perfect square, right? 64 is 8, 81 is 9, and so it's like 8 point something. And so I'm going to leave it as a radical. And what that tells me is I'm going to have one of those horrible 1 plus or minus the square root 3 over 2, right? I'm going to have irrational solutions. And maybe, if I'm working in the business world, that's not good enough. Maybe, sorry, not even the business world. Maybe if I'm going to space and I need someone to land on the moon, being off by a decimal is not good enough, right? That's all I need to know. I just need to move on with my life. I don't need to know what this one is because I already know it doesn't help me, right? So the discriminant's a way to check where you're going, right? This one tells me, nope, not going to work. Irrational solutions. Let's try another one. I actually recommend you try the last two out on your own. See what they are and see what it leads you to. Okay, see what it leads you to. Okay, let's try it together now. This would be 1 squared minus 4ac, which would be 1 minus 16, which is negative 15. What does that tell me? Well, if that's under the radical, I have a problem. But that tells me there is no answer here. It doesn't matter how far off it is. It doesn't matter if it's decimal. There is no answer here. There is no real number that is going to solve this. So what I have is two complex solutions, or two imaginary solutions. I have two solutions that do not work. So if I'm working in the real world, that's a big problem, right? That's a really big problem. If I'm trying to find the answer to this thing that's supposed to fit my business model, yeah, sorry, boss, that's just not going to happen. Like, the math is wrong, or I am wrong, or you are wrong. Like, our numbers, someone messed up. Someone's getting fired. Okay? So this is a really important one, right? Depending on the situation. But all this tells me right now in math class, negative 15, I'm not going to have real solutions for this one. Because I've got square root of negative 15. There is no real number square root of negative 15. Alright, and last one. We got to move that 12 over. Be careful, that's the 12x. That's the part that becomes our b, right? It's got to be descending order power. Not because it wouldn't be incorrect to write the negative 12x on the end. We just got to make sure that now when we plug in the discriminant, this is what we take as the b part, right? The b is always with the x. It's not just whichever order you want, right? Minus 4ac. That would give us 144 minus 36 times 9 is also 144, and that gives me 0. And when you have the square root of 0, there's only one answer to square root of 0, so this would be one solution. And one real solution at that. One real rational solution at that, because technically it's like the first case, because 0 is a perfect square, 0 times 0 is 0, but there's only going to be one answer. So I am at the bottom of my parabola. If I was doing aeronautics, airplanes and such, whatnot, then this would be the top point. This would be the crest. This would be the one where there's only one answer, and so it would be hitting right at the edge of the side, or right at the edge of space, or right at the edge of the ground, which hopefully is not a bad thing, right? Hopefully they know that and they're going to land. But this is the one with one answer, and so that's the one we want to see. Okay, discriminant itself is a gateway kind of thing, right? It's a lead-in, it's a foreshadowing. And again, do you think you're actually going to do the discriminant 10 years from now? Probably not, unless you become me and you're going to take over my job and teach math class. But what you're really going to do is you're going to want to not do the whole problem that your boss gives you. Or you're going to want to not do the whole problem because you have 87 of them to do. You want to understand how formulas work, not just how to work them. See what I mean? A computer can plug into a formula, right? But you don't want to make your computer run 87 different equations when none of them will work, because then you're going to look like an idiot waiting for 5 hours when your computer spits out nothing, right? You want to know how these things are working. Is it logical? Does this make sense, right? So real-world contexts of these are probably where you're going to find the most benefit in them. But it's important to see these types of things, the fact that you can find things from parts of the equation. Speaking of which, we're going to play a little puzzle game now. Oh no, we're going to do one more. Sorry. Try this one on your own. Forgot I put this in here. Try this one on your own, see which one it is. Because you've now seen what can happen with all of them. Okay, so discriminant 4, so 2b squared minus 4ac. 15 squared is 225 minus 1200. So plus would be 1425. Well, I can already knock out 2. It's not a 0 and it's not negative. So the question is perfect square. Ugh, I hate doing perfect squares in the calculator. Okay, so I checked 1425, not a perfect square. And so this leads me to the conclusion that I'm going to have 2 real but irrational solutions. Okay, so now a little game, fun little game. What if we went backwards? What if I didn't want to know if it worked? What if I wanted to make sure it worked? What if I wanted to know whether it's going to work? More importantly, maybe I'm in that airplane mode and I want to do airplane mode. That's not what I meant. Maybe I'm in aeronautics and I want to make sure that I only hit one thing. So find b so that this quadratic equation, 9x squared plus bx plus 4 equals 0, will only have one rational root. Okay, I want to make sure there's one answer. Whatever the scenario is that I need one answer. Okay, I can do that. I can reverse engineer this using the discriminant. I can use part of this. Instead of sitting there and plugging in b after b after b after b and finding out which one it'll be, haha, I can use the discriminant, a part of the formula, to make sure this actually works. So what does that mean to have one rational root? That means my discriminant has to be 0. So my b squared minus 4ac has to equal 0. Now there's 3 variables here, so that's a problem, right? But are there really 3 variables? Because they gave me some information in the problem. They gave me the fact that 9 and 4 are a and c. So instead, I can change 9 and 4 into the a and c spot. And we get that b squared minus 144 equals 0. And that I can solve because that's just one variable. Solve that real fast. We get b squared is equal to 144. Take the square root, plus or minus 12. And yes, it's plus or minus. Minus would also be there because I could square it and get the 144. So I actually have 2 different quadratics that would give me one answer. 9x squared plus 12x plus 4, or 9x squared minus 12x plus 4. Either one of those would work. All right, let's do another one now. Solve this one. Try this one on your own. See if that one you can find where it only has one rational solution. All right, so we'll do the same idea. B squared. This time we have the b. Minus 4a is 1, c is c. We don't know c, that's kind of the problem. So 36 minus 4c equals 0. Negative 4c is equal to 36. And so c has to be negative 9 in order for this to work. And it's not positive because otherwise it wouldn't work. All right. So that's the discriminant. Again, it's a lead-in idea, but for this one, it's just easiest. We've been working with quadratics, so it's easiest for us to see around the quadratic formula how this thing works. If you have any questions at all, shoot me an email or come see me in person. Other than that, happy homework!